video will cover the last two problems from section 1.6, so that will be example 8 and example 9. And we're going to use all the transformations that we reviewed to graph a function that has multiple transformations. So that function is here, and we have that f of x is the parent function, and this function might look familiar to you because we use that. This is my favorite function to explain transformations. We use that in algebra 2. So let's start by finding some of the reference points that we will be using to do the transformations. But first, let's identify the order of the transformations. The first one will have to be the horizontal shifting. Second will be the stretching or shrinking. Third will be the reflection. And the last one must be the vertical shifting. So I'm going to start by just listing my reference points, and those will be -4, 0, -2, 4, 0, 0, and I'm getting those points from this function. Also 2, -2, and 4, 0. So the number that tells me that there is a horizontal shifting is the number inside the parentheses, the one that is affecting x directly. And we know that horizontal shifting is counterintuitive, so the graph is going to be shifted 1 unit to the right, and that means that we're going to add. We need to add 1 to every x coordinate. So going by my reference points, -4 plus 1 is -3. Nothing happens to the y, so it's still 0. The next reference point is a -2, so -2 plus 1 is -1. The y remains the same. Next reference point is a 0, so that 0 will be, we add 1, so it will be 1, 0. Next reference point is a 2, so 2 plus 1 is a 3, so 3, -2. And the last one is a 4, so 4 plus 1 is 5, 0. So I'm going to plot those points, -3, 0. -1, 4, 1, 0. I'm sorry, I graphed this point. It's not graphed correctly, so it is -1, 4. It should be here. Then we have the point 3, -2, and the point 5, 0. Now, since we are graphing a function with multiple transformations, instead of going back to the original or the reference points from the parent function, remember this is the parent function, we're going to continue from the points that we obtained from the horizontal shifting, so the ones here. So now we're going to focus on the stretching or shrinking, and that will be given by the constant that is multiplying the function. Now, since that constant is outside, it's not inside the parentheses, it's affecting the y values. And for that reason, we're going, that tells us that it will be a vertical shrunk. And we will have to multiply every y value by 1/2. In other words, divide the y value by 2. So we're going to multiply y by 1/2. So remember, we're going by this new points here. So the first reference point will be -3, 0, because 0 times 1/2 is 0. Next point will be -1, 4 times 1/2 is 2. Next point will be 1, 0. 0 times 1/2 is still 0. Next we will have 3, -2 times 1/2, that will be -1. And the last one, we multiply 0 by 1/2, and that is still 0. So if you notice, the x-coordinates of the points did not change. So let's go ahead and plot those points. -3, 0, -1, 2, 1, 0, 3, -1, and 5, 0. And you can tell that there was a vertical compression, and that was because the constant was 1/2, which is smaller than 1. So let's move on to the next one. And when we do the next example, we're going to use the points that were used to graph the vertical shrinking. So those will be our reference points. Okay, so for reflecting, let's go back and look at the original equation. And we know there is a reflection because we have a negative sign here. Now, that negative sign is outside the parentheses, so that tells me it's affecting the y. And what we're going to do is multiply. Well, first let's establish it is a reflection across the x-axis. So we will have to multiply every y by -1. And I know we're saying x-axis, but we're multiplying the y. And think about it, if we have a point here, and we want it to be reflected across the x-axis, it will be here. And so what changes here is not the x-coordinate, but the y-coordinate. So that is why we say we multiply y by -1. So let's go ahead and find our new reference points. So the first one will be, remember we're using the ones obtained from the previous graph. And so -3, 0, because 0 times -1 is still 0. Next one is -1, 2, so that will become -1, -2. So what we're doing is just changing the y value to its opposite value. 3, +1, and 5, 0. So you notice the points that are on the x-axis, they remain on the x-axis. So we have -3, 0, -1, -2, 1, 0, 3, 1, and 5, 0. And so that will be the reflection, and we have one last thing to do, and that is going to be the vertical shifting. Let's go look back at the equation, and we have the +3, that's what's telling me that there is a vertical shift, and we know that the function is going to be shifted 3 units upward. So what we need to do is add 3 to every y. So again, we're going to use the new points, and we will be only changing the y coordinates. So it will be -3, 3, -1, 1, 1, 3, 3, 4, and 5, 3. So we want to plot the points, -3, 3, -1, 1, 1, 3. I'm sorry, I plot this point wrong again. So again, so -3, 3, -1, 1, 1, 3, 3, 4, and 5, 3. Okay, and so that will be the graph of the function that was written like this: -1/2 times f of x -1 plus 3. When you take your exam, you don't have to show me all of the steps. You could just graph the final function, but if you want to do it step by step, that will be okay with me. Okay, so let's move quickly to the next problem. Again, we're going to do horizontal shifting, stretching and shrinking, then reflecting, and finally vertical shifting. So let's go ahead and graph the parent function first. It is the quadratic function, so we have 0, 0, 1, 1, 2, 4, and 3, 9. It is symmetric with respect to the y-axis, so we will have -1, 1, -2, 4, and -3, 9. So that is the parent function. We already know the points: 0, 0, 1, 1, 2, 4, and 3, 9. Here we have -3, 9, -2, 4, and -1, 1. So those are going to be our reference points. So for the horizontal shifting, that one is given by the +3, and that tells me that we're going to subtract 3 from x, from every x. So what I'm going to do, let's go ahead and list the points here. So if we subtract 3 from every x, we will have -6, 9, -5, 4, -4, 1, -3, 0. Our next point, 1, 1, will turn into -2, 1. We will also have points -1, 4, and the last one will be 0, +9. So let's go ahead and plot those points. And so that is our horizontal shifting. Now let's move on to the stretching and shrinking. And in this case, we will have the vertical stretch. And we know that because we have the 2 on the outside, so the 2 is affecting the y. So we're going to multiply every y coordinate by 2. So our new reference points will be negative 6, 18, negative 5, 8, negative 4, 2, negative 3, 0, negative 2, 2, negative 1, 8, and 0, 18. So let's go ahead and plot those points. We do not have enough room to plot the ones where the y value is equal to 18, but if you want to, you could stretch your y-axis or not plot it at all. So I'm going to start with negative 5, 8, the one here. Then we have negative 4, 2, negative 3, 0, negative 2, 2, negative 1, 8, and that's it. So remember, this was a vertical stretch, and I know the function looks a little narrower, but remember the example I gave you of a balloon. If you stretch a balloon, it will get skinnier or narrower. So let's move on to the reflection. And, oh, actually, there's no reflection, so we can just skip that part. Great. The last thing we have is the vertical shifting, and that one will be given by the constant here, the negative 1. So that tells me that the graph will be shifted 1 unit down or downward. So what we need to do is subtract subtract 1 from every y value. And so I'm going to use our reference points that we have from here. And we will have the following points. Negative 6, 17. We know there's no room for that, but we can still write it out. Negative 5, 7. Negative 4, 1. Negative 3, negative 1. Negative 2, 1. Negative 1, 7. And finally 0, 17. Keep in mind that our graph includes more points than that. It actually includes an infinite amount of points. And we also know the domain for this graph, it is all real numbers. So don't think that this is a discrete function, it is continuous. So let's start by graphing this one, negative 5, 7. Negative 4, 1. Negative 3, negative 1. Negative 2, 1. Negative 1, 7. And that's all I can fit here. Connect the points. Make sure you do have arrows at both ends. That implies that it extends indefinitely. And so this is the end of the video. If you do have a question over the weekend, please let me know. Homework for section 1.6, it will still be due on Monday. For A-Day students, it will be due on Monday, September 14th. And for B-Day students, it is due on Tuesday, September 15th. So enjoy your weekend, but do not have too much fun. Stay out of trouble.